ABCD is a trapezium with AB is equal to 21 centimeter and CD is equal to 35 centimeter. ABCD is equals to BCD is equal to 90 degrees and ADC is equal to theta. Using as much information from the table as is necessary, calculate AD. Okay, so we have to calculate the length of AD. This is AD over here. And we have this table from which we have to use the information, whatever is required, which means that the table contains more than the required information. Anyways, so how are we going to calculate the length of AD when ABCD is a trapezium? And how are we going to use these trigonometric ratio in a trapezium? So definitely, trigonometric ratios are not meant for a trapezium. Trigonometric ratios are meant for a right-angled triangle. So what I am going to do, I am going to drop a perpendicular from A on CD. When I say a perpendicular means this. I'm going to drop a perpendicular from A on CD. So this is how it should look like. And then let's call this point as E. I'm naming this as E. So I can say I have a right angle triangle, which is AEC. In triangle AEC, I have to calculate AD, and apparently there's nothing which is given to me. But this length over here, the length from point D to point E can be calculated. The length from D to E is going to be 35. This is 35. And I can take out this length from 35. This length is 21. So if I take 21 out from 35, then I'm only left with this part, which is DE. So first of all, I have calculated DE, which is equals to 35 minus 21, and that is going to be 40. So I can say in the triangle DEA, I at least have the length of one side of the right angle triangle. Okay, this length over here is 14. But apart from this, there is nothing else which is given to me, and there is nothing else which I can calculate. So now that I have the right angle triangle, I can use the information for this line. What are we trying to find out? We are trying to find out the length of AD. AD is the hypotenuse in this right angle triangle. And with theta being at D, 14 becomes the adjacent. The formula, the trigonometric ratio which connects adjacent and hypotenuse is cos. So I can use cos theta is equals to adjacent upon hypotenuse. Adjacent is 14 and hypotenuse is AD, which I have to actually find out. That's all what I can do. As long as I do not know the value of theta, I'll not be able to calculate AD. And I cannot calculate theta. I'm not given theta. What I'm given this table. In this table, they have mentioned that cos theta is equal to 7 upon 25. So what I'm going to do, I'm going to replace cos theta with 7 upon 25. Remember that this is paper 1. You will not be able to calculate the value of theta from any one of these because you will not be able to take the inverse trigonometric function of any of the ratios. So I'll replace cos theta with 7 upon 25. I've replaced cos theta with 7 upon 25. So 7 upon 25 equals to 14 upon AD. Now I can solve and find out the value of AD. What I am doing, I am moving AD to that side. Let's say cross multiply. 7 times AD is equals to 14 times 25. And at the same time, I can move this 7 over here now. I could have done it in the one step. But just to make it simpler to understand, I am performing the additional step. This was 14. I can cancel 7 with 14. I'll be left with 2. And I multiply 2 with 25. This is going to be 50 centimeter.